Hello everyone, welcome to my channel. Today we are going to see exercise 1.2 real numbers problems. Okay, here the first problem. Express each of the following numbers as a product of its prime factors. Okay, first of all, what are the prime numbers? The numbers which have only two factors. The two factors must be 1 and itself. Okay, so those numbers are called prime numbers. 2, 3 and 5, 7. Next prime number 11, 13, 17, 19, like that. Okay, so prime numbers means the numbers which have only two factors. The two factors are 1 and itself. Here the first problem is 140. So first of all, we have to find the prime factors for 140. As a product of prime factors we should write, right? So 140, first least prime number is 2, and here in one's digit 0 is there, so it is divisible by 2. 2 sevens are 14 and 0. Again 0 is there, it is divisible by 2. 2 threes are 6, 1 0, 10 here. Okay, 2 fives are 10, and here in the digits, unit digits place or ones place 5 is there, so it is not divisible by 2. And the next prime number 3. So if we add these digits, sum of digits, 5 plus 3 8 and 5 plus 3 8, it is not divisible by 3. Okay, next prime number 5. So 5 sevens are 35, right? So clearly we can write 140 as 2 into 2 into 5 into 7. So 2 into 2 means 2 power 1 into 2 power 1. When these bases are equal, the powers will be added. So 2 square into 5 into 7. Okay, so this is the prime product of prime factors of 140. Here the second one is 156. Okay, so 156. So here in ones place 6 is there. So what is the divisibility rule of 2? If 0, 1, 2, 4, 6, 8 are in its units place, then the number is divisible by 2. So this 156 is divisible by 2. So 2 sevens are 14, 1 6 16, 2 eights are 16. So here 2 threes are 6 and 1 8, 18. So 2 nines are 18. Now it is not divisible by 2 because 0, 2, 4, 6, 8, any of that digit is not present here. So it is next prime number 3. What is the divisibility rule of 3? If sum of digits is divisible by 3, then that whole number will be divisible by 3. So 9 plus 3, 12. So it is divisible by 3. So 3 ones and 3 13s. So 156 can be write as 2 into 2 into 3 into 13. So in this way we can write as the given number as the product of prime factors. So again here we want to find out the prime factors. So clearly here 5 is there in units place, so it is divisible by 5. 5 sevens are 35. Okay, so most of the students feel it as difficult some students. So it is normal division only. 5 sevens are 35. Here 8 minus 5, 3, and 2 comes here, right? So like that only 5 sevens are 35 and 3 will be there here remaining, and 3 to 32. How many times 32 will be divided by 5? Again 5 6 are 30. 5 6 are 30. 2 will be remaining. And next this 5 comes here. So here 2, 5, 25. 5 5s are 25. I think you understand, right? So normal division only, but all this calculation will be done in your brain. Okay. Again 5 is there in units place. So it is divisible by 5. 5 ones are 5. 7 minus 5, 2. 26, right? So 5 5s are 25. So 1 will be there. 1 5. 15. 5 3s are 15. Okay. So 153. Next prime number. So if we check with any prime number, it won't divisible. So 17 nines, if we observe 17 table, 17 nines are 53. Again 3 3s are 9. So 3825 can be written as 5 into 5 into 17 into 3 into 3. So 5 square into 17 into 3 square. So this is the product of prime factors of 3825. We will see next problems. The fourth one is 5005. Okay. Product of its prime factors. We should write as a product of prime factors. So in the rough work we will do this calculation. Okay. 5 ones are 5, 0, 0 and 1. Okay. So here if you observe, next prime number after 5, next prime number 7. Here 1 is there, it is not divisible by 2 clearly, and it is not divisible by 3 also. 1 plus 1 2, right? So check it. We check with 7. Actually students, the divisibility rule of 7 is somewhat typical. That means it is not mentioned in our textbooks. We will see some other time. Now we will check with 7. 7 ones are 7. The remainder is 3. 3 0, 30. 7 4s are 28. Here the remainder is 2. 2 1, 21. 7 3s are 21. So we got 143. So now we want to check this 143. Again clearly it is not divisible by 2. So not 5. In 3 plus 1, 4. 4 plus 4, 8. So it is not divisible by 3 also. So next prime number 11. What is the divisibility rule of 11? The sum of digits in even places and the sum of digits in odd places. First of all we should do, and the difference between that sums must be 0 or 11 or 22 like that. That means multiples of 11. So 11 ones are 11. The remainder is 3. 11 3s are 33. So 5005 can be written as 5 into 7 into 11 into 13. Okay. So in this way we can write. Next here fifth problem, 7429. So by side, in the side we will solve like this. Okay. Here in units place 9. So it won't divisible by 2. We'll check out the sum. 7 plus 4, 11. 11 plus 2, 13. 13 plus 9. 13 plus 9, 22, right? So again it won't divisible by 3 also. Like that, if we check, it is divisible by 17 prime numbers, right? 17 fours are 68. So here the remainder is 2. Okay. Next 17 threes are 51. The remainder is 11. So here 119 will be there. So 17 sevens are 119. Okay. So 437 we got. So again it is divisible by next prime number 19. 19 twos are 38. So here the remainder is 5. 5 7 57. So 19 threes are 57. So 23 also prime number. So 7429 is equal to 17 into 19 into 23. So in this way we can express any of the given number as product of its prime factors. For this, first of all, you know what are the prime numbers. Okay, I think you understand this problem. Thank you.